Morning, everyone. Well, that's quite loud, isn't it? Welcome to Munich and welcome to the Dev Day with AWS. My name's Rick Harvey. I'm a technical developer evangelist at AWS. What does that mean? It means I go around teaching AWS and our technology stack to people like you. But it also means I want feedback from you. So if you've got anything you want to see in products, if you've got anything you want to see improved, new ideas, come to us. Tell us, reach out to me, especially on Twitter. I'm very responsive on Twitter, so please reach out on that. And tell us your ideas, tell us where you want things improved, and it's my job to get that back to the development teams and help move our products along so they suit you better. So today we've got two sponsors, Replay and Intel. Replay are going to come up and do a little slot in a minute. Danilo's going to come up and have a chat with you. But first of all, I'm going to do Container's State of the Union. I'm going to tell you about the container landscape on AWS and the offerings we have. So let's dive into this. First of all, who's using Docker already? Show of hands. Okay, keep those hands up. Who's using them in production? Oh, not many fell. That's quite exciting. That's quite exciting. There's a bit of a change recently to a lot of people doing this in dev and test, or on their laptop, and then production is starting to become more and more common pattern now, so that's really good to see. So most of you know these first few slides. Why are containers and why are people running them? Well, it's a way of packaging your application, your config, and data all in a nice bundle and creating a repeatable deployment. I come from an ops background, and I remember the days when people used to say, well, it worked on my laptop. And you try and put it in production, it just doesn't work. Because somebody developing an app on the Mac is going to have a different library directory. They're going to have different dependencies, different versions. And then you took that to a production Linux server, and it just didn't work. And it was always painful. Every deploy was painful. Docker kind of eased that, and Docker's the most popular one here, but there's obviously container engines like Rocket and Containerd to look at as well. So one of the first questions that we always used to get asked was, why not use a VM? Why put it in a container? Why not use a VM? And this sort of slide you'll have seen probably time and time again, especially at Docker meetups. If you're going to boot a VM, you have your server, you have your host operating system, and a hypervisor that sits on top. You then have another operating system to look after, and then you have your libraries and binaries, and then eventually you have your application on top. And it's quite a heavy stack compared to a container, which you have your server, your host OS to look after, your Docker engine, and then your container is very lightweight because it shares the kernel with the host below. This means updates and that are simplified to some degree. Where you can share bins and libraries, they are shared between applications and the host system in some cases. So you can make a much more lightweight instance, for want of a better word, container. You can make a much more lightweight version of your application to ship around and move it between different environments. And this gives you a benefit of speed as well. So starting a VM typically take 2 to 3 minutes for a full boot. A container, 3 to 5 seconds to start up and be fully running and operational. So if you're doing things like scaling, especially in a media world, that's really, really important. I come from a media background. I worked for a television channel over in the UK, and we had advertisement breaks. And as soon as we put out a URL at the end of a session, the general public was on that website like that, really, really quick. There's one example we've got where we went from 30K a second background traffic to 3 gig a second traffic in 3 seconds. It was a very, very popular show. But that amount of traffic with auto-scale technologies, with VMs or instances that take 2 to 3 minutes to start, just doesn't cut it. You have to pre-scale. But with containers, what we found we could do was pre-scale to a sensible level, but if we found capacity was reaching that 10% threshold we like to keep as overhead, we could add containers very, very quickly in the background. And this kind of relieved a lot of our problems with scaling while I was doing a transmission on air. It made my life a lot easier and less things broke and melted, so it was great. So containers, I've already said, they're very portable. You can move them around between environments. They're very lightweight, and I've shown you why. It's also a standardized packaging format, which is great because I can run them anywhere. I can run them on my laptop. I can run them on a Linux box. I can run them on Mac. It's fantastic. They're very easy to deploy, and you kind of get that comes hand in hand with this. You end up breaking up your monolithic applications. So whilst you can run multiple processes inside a container, everybody always says it's best to just run one process. Now, why is that? Well, when you're monitoring a container from the outside, you're looking at PID1 running. You're looking at the first process to run. And if that process dies, your entire container dies and it gets restarted by your scheduler. That's how it's supposed to work. But if you're running 5 things inside that container and PID5 dies, Docker's not looking for PID5 dying, it's looking for PID1 dying. So your application might be broken, but the container remains. It's not replaced, it's not restarted automatically. So that's why we kind of say run one process per container. And with that, you get this magic, microservices go hand in hand with containers. You kind of get one automatically through the other because you have to architect that way if you're going to do it properly. So let's have a look. 2014, we started doing things with Docker on EC2. That's a lot of work. Running your own Docker infrastructure on top of EC2, manually placing containers. You had to do a lot of work. You had to work out if you've got enough resource on that particular instance. You had to work out what happens if that fails. You then had to plumb in your own things like load balancers. There was a lot of work you had to do yourself. So customers came to us and they all said, make this easier for us. You'll notice this slide comes out a lot on the way through here, so keep an eye out for this particular slide. So make this easier for us. And we said, how? And said, well, we don't want to be manually placing containers. We don't want to be manually adding load balancers. We don't want to be having to write our own monitoring systems to make sure everything's still running. So this is what people were doing. They were looking after multiple EC2 instances with multiple containers on, and an admin was going in there and manually doing this. So management of this was very, very hard. So we came along and we introduced ECS, Elastic Container Service. And this, I just put a few animations in for effect there. This basically, we built a management plane, which is a scheduler. Now, the scheduler's job is to look at the resources on your EC2 instances and decide where best to place your container. It also manages multiple copies. If you've got one container but you want to scale that and run 5 versions of it, the scheduler will make sure that with a placement strategy, that runs 5 times. And you can do things with a placement strategy like, say, make sure it's on a unique host. Make sure they're nicely spread across all availability zones for ultimate high availability. There's all different strategies which Brent will cover later in our ECS deep dive, which is the next session. So we built this, and we were very happy with it. It came out. We removed a lot of heavy lifting for you. You didn't have to do the scheduling, the placement. You didn't have to write your own health checks for the Docker containers. And we took care of all the management control plane. So there was no extra servers for you to run. You don't have to spin up any more EC2 instances and run a control plane and an API and all those complex bits. And then on top of that, there's no cost to that management control plane. All you have to do is bring your worker nodes. So you just bring the cluster. You don't bring the management. You connect your workers to the management. We look after the management control plane. We do the updates on there, the OS patching, the agent patching. We look after that. You just look after your workers. So we made it a lot easier. It's highly scalable, high performance. We boldly say it will run to clusters of any size. We've not met anyone yet who's had a problem with scaling with ECS. It scales very, very, very well. And it's also got very good deep integration with other AWS services. So one thing that came out of this was we wanted to make containers a first-class citizen within AWS. We wanted to make sure you could use IAM policies. We've integrated things such as elastic network interfaces for a task. So you can have a very fast access into AWS. You can extend your VPC inside your container cluster. All these things are really, really useful when you're interacting with other AWS services, or you've got EC2 instances running other parts of your infrastructure. We've got a large range of customers using this, and I'm going to focus on one in a second. GoPro down here, the little cameras for jumping off of cliffs and doing crazy things and putting the videos on YouTube. GoPro went heavily in on ECS, and they love it. They think it's great. And one of the benefits of this was they reduced their EC2 footprint by 70% by moving to ECS. They containerized all their applications. They got better value for money by packing more containers onto less hosts, and a 70% reduction in EC2 compute footprint. That's a huge cost saving that comes along. So it's well worth considering if you're not doing this in production already. 2017, we did a lot of updates, and this probably isn't all of them, to be perfectly honest. I think one thing that's missing off of here is at the end of 2017, we did service discovery to allow containers to automatically register themselves with DNS. So you've got service discovery built in. You create a local domain, and then each container can have its own namespace in there. So finding other tasks and other services from other tasks and services becomes quite trivial. We added Windows container support. We've updated the CLI. It's actually 1.1 now, isn't it? 1.10 now. We've got cron and CloudWatch event task scheduling. A whole host of updates, and these aren't going to slow down. One of my favorites is that EC2 can actually take advantage of the EC2 spot fleet, which means that if you've got containers that you don't mind being killed off and replaced very, very quickly with a 2-3 minute warning from us, you can actually take advantage of using EC2 spot instances, which will save you a lot of money as you go along. So what underpins all this? We've got Amazon ECR. ECR is our container registry. It's a private registry. It's fully managed. It's very secure. Integrates with IAM controls. It's highly available. You don't have to do any of the scaling of it either. And it simplifies your workflow. So I've included here a little bit of bash that I always use for using Docker login from my laptop here. If I run this, this basically runs a Docker login prompt by pulling some credentials out of IAM for me. That means I can then use the Docker tools to push my images up to the ECR repository. Really, really simple. ECS is also integrated with ECR, so it can pull images down, and you can create IAM roles to allow other hosts to access your ECR repositories as well. So it's all fully integrated. So ECS, talked about our offering for running containers. What about Kubernetes? Kubernetes is the big one. Everybody's used Kubernetes or heard of Kubernetes. It's now included in the Docker install on Mac if you're using the bleeding edge version. It may have filtered down lower now. Kubernetes is where my background is. I've used Kubernetes heavily in the past for several ticketing companies and did some big scale deployments. Also for the Rugby Six Nations back home, did a Kubernetes deploy. So this came about from the CNCF did a survey, and they found out that 69% of people running containers that they surveyed were running containers on AWS. And of that, 57% of those were running Kubernetes, and they were doing it the hard way. They were building their own clusters, and they may have been using a commercial offering such as Tectonic, or they may have been using open source projects like COPS. I'm going to talk quickly about COPS. COPS is an orchestration tool to go and build a cluster for you in AWS. It runs a Debian image as default, and by default, it wants to build your entire setup for you. It wants to build a VPC for you, create subnets. You can override this. But typically, what you get when you build a Kubernetes cluster, you have to build some masters. The master servers run the scheduler and the API and bits for placing and cloud knowledge. It's aware of your cloud environment. This is a bit that talks with all the infrastructure. It's backed by something called etcd, which is a key value store. And this basically stores all the state of your Kubernetes cluster. And then on top of that, you've got to bring worker nodes in. And this is where your containers run. And if you're going to do this properly, you're going to build it into other availability zones as well. And then you probably want to subnet everything off from each other. There's a lot of moving parts to this. It's quite complicated. There's a lot of work to do. COPS actually simplifies it a little bit by merging your masters and your etcd onto one host. But you can split them out, especially if you're building a very, very large-scale cluster. You needed a lot of etcd servers for throughput. This is a lot of stuff to manage. These are a lot of servers you've got to put into your patching routine to make sure the OS is up to date. A lot of things to monitor. So we've got customers who do this. Monzo, for example, UK fintech startup bank, they run Kubernetes, and they gave us a great quote. But this quote also highlighted the fact that it's hard. So they run this. They run multiple masters, hundreds of workers, which mean they need a lot more etcd servers. So they've got a lot of infrastructure they're now managing. And their quote is saying, Kubernetes is brilliant. We're pleased with the result. It works very well on AWS. But it's not for the faint of heart. Now, this is something we heard again and again from customers. We love running Kubernetes. We like doing it on AWS, but it's hard work. And yet again, make this easier for us came out as a request. So we listened, and we brought out AWS EKS, Amazon EKS. This is a managed control plane of Kubernetes where you just bring the workers again. Very much like we do with ECS, but we take away all the management of the etcd servers and of the management control plane. We manage, we patch that, we scale that for you in the background. We remove the heavy lifting for you. So one of the key things we wanted to do with this was to make sure it was an upstream open source experience. This was our key tenet. When we first announced this, the biggest question we got was, this isn't going to be AWS Kubernetes, is it? It's not going to be slightly different to every other Kubernetes I've used, either on-prem or in other providers. We said, no, absolutely not. We're going to make this upstream experience for you. And anything we build on top, like integrations with IAM or network load balancers, we're going to push that back to the upstream open source project as well. So we've been doing that. And now if you're running Kubernetes on AWS, you can actually take advantage of network load balancers. The ingress controller is there for that, so you can actually consume that now. And it's a project that's out there that we've contributed back to the Kubernetes project. And we also wanted to make Kubernetes a little bit smoother integrating with other AWS products. For example, if you're going to do IAM and do IAM integration for your containers at the moment, why would you want to do that? Well, the first thing is that on a host level, you might only want the host to be able to do certain actions, such as add itself to a load balancer, or auto-scale actions if it's a master. Your container itself, you might want to give permissions to that container to write to an S3 bucket. Now, the best practice way of doing this is to use an IAM role and not use API keys in your code. Do not use API keys in your code. I say this quite a lot when I'm presenting. Use an IAM role. But Kubernetes out the box, to do this, you've got to give that S3 permission to the host. Well, if you give it to the host, any container you run on top inherits those permissions. So you might have a container that you absolutely do not want to have any permission to go anywhere near S3, but it's got it because it's running on the same host. So how do you get around this? Well, there's an open source project called Kube2IAM. And yet again, this isn't for the faint of heart. What you have to do on your hosts is run a set of IP tables that looks at the container network, redirects any calls to the metadata service to then make a call to STS, and then pump that through another container called Kube2IAM, and then do an assume role. This way, you can make each container have its own IAM role. But it's quite hard work still. So within EKS, we're working on smoother ways of doing this, and smoother workflows for you and making it easier without that heavy lifting there. So EKS looks very like ECS. Management control plane handled by us, worker nodes that you bring along. To bring worker nodes along, it's very, very easy. We provide an IAM, an AMI, that you can just start and give it some information about which cluster it's joining, and it will join. And we also publish a SNS topic that if there's an update to that, that AMI, it'll get updated and you can auto-scale and replace your nodes on that. And you connect to EKS using the standard toolset, kube control. There's a little bit of IAM integration there to go and get your credentials to talk and do the RBAC authentication in Kubernetes. But we won't dive deep into that because there's an EKS session coming in a couple of sessions' time. So the next thing that people said was, great, you're doing the management control plane for us, but managing these workers and these nodes is still hard work. I've still got to patch the OS, I've still got to patch the agent, I've still got to do a lot of work here. And people were like, yeah, again, can you make this easier for us? I told you this slide was in a lot. So we introduced back in November Fargate. Quite a strange name, but Fargate at the moment is working with ECS, and Fargate not only manages your control plane, but it also manages your worker nodes. You never start an EC2 instance. In fact, you'll never see an EC2 instance running in your account. All you do is give us a container and we place that and we manage the resources. And we only charge you for the container running. We don't charge you for the whole EC2 host underneath. We look after all that for you and the availability. So if you tell us when you create your Fargate cluster to go in 3 availability zones, we know where to place hosts and manage those hosts. And this really changes workflows for people. You can now really just concentrate on your app, putting it in a container and giving it us, and we'll run it. We'll scale the infrastructure behind. We'll look after it. We'll do the patching. It really lowers your management overhead of infrastructure. And that's the key game for Fargate. It scales seamlessly on demand. It's one of the... Fargate is now my favorite AWS service. For well over 10 years, S3 was my favorite service. I love the simplicity, but I love the integration with every other service, CloudFront, hosting websites, Lambda. But now Fargate, I've sat down and played with it a lot to do demos, which you'll see one later. It's so simple to write a container and get it into a production state without doing any hard work of creating clusters and managing those clusters. So it's a real revolution in the container world in my eyes. So you don't have to worry about doing any service meshing, any capacity planning. All you do is give us a task, and a task is a collection of up to 10 containers, and we run it for you. We connect the network load balancer. It means you just focus on your job, which is building a great app in a container. And if that's all you've got to focus on, you're not focusing on infrastructure, well, things really, really improve at this point. You can spend all that time that you used to do on management on innovating in your product and making your product better and better and better. You get happy customers. You've got happy customers, that means we've got happy customers because you'll be happy as well. So taking this heavy lifting off you is to help you and help you with your management life cycle there. So in practice, when you create a cluster, you can actually start up and you can have a hybrid cluster as well. So you can have Fargate, and if you notice a difference on here, we've got no CPU and memory utilization visible and no container instances, and EC2 instances. And you can actually push those into one cluster. Now, why would you want to do that? Well, it just depends. If you've got things you're doing special on EC2, for example, let's say you're doing a kernel tweak, or you're wanting to do some connectivity via a proxy that you're running locally, or you're putting some network attached storage onto the host itself that Docker's going to be able to access. Well, you need access to the host level. Within Fargate, you can't SSH into any of the servers because you don't see the EC2 instances underneath. So sometimes a hybrid cluster is a good way to go. One of the other things as well if you're running a Fargate container, and I'll cover this in a little bit more depth in a later session, if you want to get into that container, you want to SSH into the host underneath and then run Docker exec and drop into bash and do things in the container, which is naughty, you can't. But with one line change in your CloudFormation or your task definition, depending on how you're doing it, you can move a service and a task from Fargate into EC2 and back again. It's a one-line change, and it's the difference of writing Fargate or EC2. So it's very, very easy to move between the two. So if you actually need to get into your container for debug purposes, you can do it by running a hybrid cluster. So all of this, all these containers on AWS, it's changing compute. You no longer have to just consume EC2. You can now think of containers and take containers as a compute primitive, a first-class citizen in AWS. It can access IAM roles. It can have an elastic network interface. All these things are available for it. And it's not just really containers that's a first-class citizen and a compute primitive. It's actually a task. Now, what is a task? I'm talking ECS style here. So ECS has a task definition. In a task definition, you can specify up to 10 separate containers. And these are closely related containers. If you're familiar with Kubernetes, it's the same principle as a pod. These closely related containers will run on the same host. They'll run together. And they'll share an elastic network interface if you're using the AWS VPC networking model. And one of the bonuses of that is they then share a local loopback as well. So if I've got a Apache container with PHP on it, and I'm running an app, and then I've got a container that's running MySQL, I don't even need to do service discovery at this point. What I can just say in my application code is access MySQL on localhost 3306, and I'll get access into this other container that's isolated off, but it's sharing an elastic network interface, and it's sharing a local loopback between those containers in the task. And that's quite useful and powerful when you're stitching a lot of things together that's closely related. So we have IAM roles for tasks. We can also auto-scale tasks. We can look at a task, and you can use CloudWatch metrics. There's a whole host of CloudWatch metrics that get emitted from ECS that you can use and consume. And you can scale the task within your cluster. You can also scale the cluster as well, because if you're using EC2 type in ECS, you can scale the cluster and the capacity. If you're using Fargate, you can stop thinking about that. We do that for you. So you can scale the task inside. By scaling the task, that's how many copies of that particular container you want to run. So if we look at a really simple example, and we talk about, let's say we've got a little Nginx service running, and we start off and we're running 3 copies. We're running 1 in every availability zone. And we look at that from CloudWatch, and we see it's getting busy. We can trigger an auto scale, and we can say, actually, run 6 versions of that container, so we can scale it. It integrates with load balancers very, very easy, so it'll attach to ALBs and network load balancers, or elastic load balancers, depending on if it's ECS or Fargate. There's some sort of differences. And task networking, which I went into and explained with the ENIs a second ago. So all this is to enable you to bring your containers, not worry about anything, let us do the heavy lifting. And also allow you to get down to a really granular level of control from your application into the rest of the AWS world. So why have we got so many ways of doing containers? Why is there ECS? Why is there Fargate? Why is there EKS? Why can I run my own? Well, options are good. We don't want to force you into one particular way of working. Everybody's got systems that they're bringing over from on-prem deployments, or they've got particular ways they like to work, or particular technology stacks they want to work with. We're not going to force you into using ECS when you might prefer Kubernetes. We're not going to force you into not using Docker Swarm. You can use all these on EC2. Fargate also allows you to run hybrid clusters, so you've got that option. And options are good, yet again. Options are good. It's all about you and how you want to run your workload. So that's why there's so many different ways. And these different ways, let's have a look at our landscape at the moment. That should actually say ECS on the end. We've got ECS that's available. We've got EKS. We've got Fargate for ECS. And later in 2018, we'll be doing Fargate for EKS. That's quite a mouthful to say, isn't it? So Fargate for EKS will basically be, not only will we manage your management control plane of Kubernetes, we'll also manage all the workers for you as well. So you won't have to worry about updating and patching those and keeping those running. We'll do all that for you, and we'll scale it a very, very similar way to how we do Fargate for ECS. So you'll be able to have lots of control, roll it yourself. You'll be able to have a way of not worrying about the management control plane, and you can do that with EKS, COPS, or eventually Fargate for EKS. So let's dive a little bit deeper here. ECS, why is it good? Great integration with the entire AWS platform. Links in with all these services that we're looking at here. It scales to support clusters of any size, and there's great service integrations with ALBs and NLBs. EKS, we manage that control plane for you. We take away the complexity of running masters with API servers, schedulers, cloud controllers. We take all that away. You just bring your nodes. We do automated upgrades to the master service for you. And we'll always keep 2 backwards compatible ones in. So if you're running 1.9 at the moment, when 1.10 comes out, we'll also run 1.10, 1.9, and 1.8. And we're working on really good integrations with other AWS services on this as well. We then have Fargate, which basically gets rid of infrastructure for you. You don't have to think about infrastructure at all. We're going to enable you to do that and just bring your containers. It also gives you slightly cheaper costs because you're only paying for the container running, not the entire EC2 instance. And then you can roll your own. You can bring Kubernetes and run it on COPS. So we've got all these different ways of doing it, but for a reason, to give you options, to let you deploy how you want to give you the amount of control you want over your infrastructure, or to let you not have any headache and heavy lifting of running that infrastructure. So there's bits in between, but they're the 2 extremes. That's a lot of options to choose from, though. Nathan Peck wrote a really, really good article on Medium. We'll send these slides out after anyway. We'll send you a survey out. If you fill that survey in, we'll send you the slides back out. It's a little bit of a blackmail to get some feedback from you, but we'll send you the slides if you fill our survey in. So this is a really, really good blog post about which one do I choose? Do I choose ECS, EKS, or Fargate? This will help you decide and plan your method along there. I've also got a load of getting started guides for you. I'll highlight one of these a little bit later, and I'll talk about it after replay have come on. So these are great for going through and having a look and learning how to do, how to get started on your container journey. Hopefully the sessions that we're going to do later will give you a lot deeper insight into how to use these technologies. We'll go a lot deeper on the tech stack, and you'll learn quite a lot from that from an operational point of view. So, Reply Partner Spotlight now. I'm going to hand over to Danilo over here, who's going to come on and tell you about the containers work they do. So I'll hand you this. Big middle. Cheers.
So, hello. No, working? Not? It's okay? So guys, it's a pleasure to see you here today. Thank you very much to Rick for this really interesting introduction on containers. We will try now to give you some additional information, at least from the reply point of view. So my name is Danilo Albino. I am the partner at Reply and the managing director of the unit in charge of the AWS Cloud Computing Services. I will show you some slides on, okay, so those are the names of my colleagues. I will show you some slides on reply to give you an introduction and to also make you understanding which is then the connection with the containers. No? Reply, let me say, is a kind of containerized company, no? Because differently than maybe most of the companies on the market, it's not a kind of monolithic organization, but is made up of a large number of units. So each one focuses on a specific topic. So very much competent on each topic that goes from cloud computing, Internet of Things, big data, e-commerce, artificial intelligence, whatever you have in mind. No? We come from an origin of being a system integrator for very complex IT platforms, infrastructures in the back end, and from consultancy services. But of course, there has been an evolution towards what we can call all the enablers of the digital transformation. This is just an overview of the offering. Okay, of course, I will not go into the details here, okay, but it's just to show that Reply is really able to go into the different verticals of the industry consulting. And while on one side, actually, so we manage all the technology platform, and as I said, really leveraging on the enablers of a digital transformation project. On the other side, actually, we are able to manage all the digital touch points, no, for the final users. So this puts us in the situation, the condition to have an overview from end to end of the technical value chain, but also of the business value chain. A few figures on Reply to show you which kind of companies, as you may see there. So Reply is a very healthy company. It has been founded in Italy 20 years ago. Always a kind of an amazing performance in terms of all the financial indicators. It's also a public company, so you will find all the information on the internet, no, on the public financial website. And it is the first company ever in the history of the Reply stock exchange, in the history of the Italian stock exchange in terms of performance. No. You can also see our footprint. We are mainly focused in Europe, of course, Italy, but Germany is our most strategic development country. We have also a strong presence in the US, and of course, no, the footprint of the operation is much larger. Specifically, this is an overview on the cloud computing and AWS. No. If you are familiar with the APN portal and you go looking for an AWS partner, you will not find any other partner more competent and qualified than Reply. No? So we are partnered with AWS since 2010. It's already 6 years in a row that we are a premier consulting partner. So as you know, the highest level of partnership with AWS. And we held, let me say, all those competencies. No? So from the Internet of Things, big data, DevOps, so you read it. No? We have here in Germany over 60 certified consultants, and in over 10 years, we were able to manage over 500 projects on cloud already. So this means, of course, some small POCs, no? But up to huge projects, up to huge migrations. No? So we call it not mass migration, but massive migration with companies that have moved to the cloud over 10,000 servers. So really very large cloud adoption. And normally Reply works with corporation, no? With worldwide companies. You can see a few names there that you can recognize, worldwide brands, very present also on the German market, okay, starting, let me say, from the telco, Vodafone, Telefonica, but also the industries, the automotive, so all the automotive, BMW, Volkswagen, European Central Bank, Fiat Chrysler Group, and so on. This is still an idea of, let me say, our offering and our focus. As you can see on the left, we have, so you recognize the most important, the most relevant areas of business nowadays. So really, let me say, the native cloud technology, which for us means cloud native development, and migrations. But you see also the ability to work on the IoT, specifically connected devices, as well as big data. And for us, it's very relevant also the e-commerce. As you see, so most of the companies that they have IoT programs. At the end, they have to implement also a big data solution because they are collecting so many data that will be crazy, no, not then start up, not continue now with the big data solution. But then when you have connected devices, especially for the mass market, not for the industrial environment, but for the mass market, you are addressing a new type of users, okay, so very digital, very enhanced users. You cannot use the traditional no, e-commerce capabilities. No, you really need different CRM and different e-commerce capabilities. And that's the reason why we see a hype also in hybrids and shopware, specifically on e-commerce. Now, the message behind this slide is that those areas, which normally are innovation areas for most of our competitors, those are already very much consolidated at Reply. So this is our business as usual, the business of every day. What we do is that actually we try to follow and to push on the innovation, especially coming, let me say, from the reinvent each year, and therefore we are switching more and more, okay, on topics as you can recognize there, no? Of course, all the machine learning and artificial intelligence, but as you see, no, the stream of containers is very much important, as well as all is related to serverless adoption of new features, so to push the Aurora DB, also in serverless that you know is available now, no, and not to forget actually, so the security, which is always a very relevant topic, no. Okay, so as you see here, so far I told you something about Reply. Those are my words. I'm from Reply, no? So normal that I'm trying now to give you a nice picture of the company. But this is actually the view of Crisp. No, I assume that most of you, you know Crisp. Crisp is an independent company. It's we can say, the equivalent German Gartner. And Crisp is positioning us since 2 years now as the leader in the hybrid and public managed cloud quadrant, no? Now, the reason why, of course, I gave you this introduction is not only to show Reply, because, of course, we are the sponsor of the track, so I have to tell you something about Reply, but because I really ask you to trust a company as Reply, because at Reply we manage technology every day. So we went through a container adoption and approach since some time. We have experienced really a large number of projects already, and there has been an evaluation process behind, okay, that has brought us to combine this containerization approach with the cloud, and specifically with the AWS cloud. I give you the floor now to Federico, as my colleague. He will recall some of the concepts that Rick has already introduced during this track, just then to show you some concrete examples. Now, you remember the question from Rick at the beginning. So, do you know containers yet? How many of you have seen, let me say, containers in production? We have really a large number of projects. We will show you a few details about some exemplary cases, which, by the way, refer to some of the brands that we have seen. So very relevant companies using large containers application in production since a while already.
Hi all, I'm Federico. I'm a solution architect in Reply, and I will show you a bit the technology, how it's used in Reply for this topic. So first, let's start with a little recap on the container history, let's say, because everybody now is talking container, but actually the technology is quite old in technology terms, let's say. Because the technology is around since 2004, so it's almost 15 years that we are talking containers. Of course, it hasn't been since Docker came out that this technology had a huge jump. With Docker now we are used to look at that as a synonym of the container technology. So today, actually, the figures are quite impressive for their company. The key features, of course, of containers are mostly speed, portability, and efficiency. Speed because it's, as you may have experienced, running containers is quite fast. For spawning up, you don't have to wait for a machine to come up, etc. Portability is because containers lets you encapsulate your application and move it faster from platform to platform. And efficiency is, of course, because you can improve server consolidation and application consolidation to reduce costs. This is a slide similar to the one we were shown before, and yeah, it's pretty evident how we have less layers, so the technology is leaner and faster. This translates in a market view, let's say, because now 3 out of 4 new projects that came out in the market are about current application modernization, and that's really important because everybody is trying to build on top of what they have, but making it, let's say, modern and ready for the new infrastructures that we are using. And that's why if we look at the cloud, 80% of the companies that are looking to build a cloud strategy, they are actually looking at Docker and container technology to empower their journey to the cloud. And of course, since we are always talking about microservices and DevOps, Docker allows to adopt these kind of practices and leverage all of their benefits. Now let's talk a bit of what we do with containers at Reply. If we start, when we first start to adopt the containers, we've concentrated on the 3 main benefits, of course. We try to translate and bring these benefits to our customers, of course. So the first one, of course, is portability. We try to show our customers how they can improve their services, their application, and make them more portable, even when they have maybe to go to the cloud for the first time. We want to show them how the isolation brings benefits in terms of mitigating the crashes and possible faults in the application, and also some security risk limitation, of course. And if we talk about the cloud, we know that one of the main selling points of the clouds and the benefits of the clouds is scaling and availability. And of course, having an application containerized, it's really helpful if we want to leverage all this power of the cloud. But of course, with great benefits come also some drawbacks. And that's that you have to design your application for being containerized. You have to understand if your application is containerizable, and of course you have to take care of security design to avoid mistakes. Oh, sorry. And that's we of course have faced all these problems and came up with solution for that. First, we try to build knowledge on the technology by doing trainings, practices on all the technologies available, including, of course, cloud-native solutions, AWS in premise, let's say. And from this knowledge, we gain experience because we of course, proposed our knowledge to our clients, and they trusted us, and we started doing really complex enterprise project of integration and migration to the cloud with containers. And all of this allowed us to build a methodology. This methodology we are following right now allows us to be fast, efficient, and agile, of course, in delivering the solutions. And this has led to results, of course, because we have now dozens of projects in production for the brands Danilo presented you before, that are global brands, and but we build them for in Germany. So I will show you briefly some use cases, some of these projects. Let's start with a telco operator and their cloud streaming platform. Basically, this platform is intended to be able to ingest data from different sources, being databases, log data from machines, application logs, and etc., and be able to, on nearly real time, streaming that to different processes, components, mainly Kafka now, but more are to come. And as you can see, we are leveraging Kubernetes already in 2 of the layers, the streaming layer that is taking care of ingesting the data and bringing it to the batch layer for storing and building a data lake in S3. and also delivering it to the microservices layer, where we have now Kafka streams to process this data and deliver dashboards, API, REST calls, and whatever. For another German car company, we built instead an highly available data processing and analytics solution for their car sensors. This is also based on all AWS native technologies, and we tried with containers and let's say the power of the cloud to being able to being always highly available, and that's why also we implemented a green-blue deployment, let's say. During the deployments, for example, we literally duplicate the whole infrastructure, and for a brief period of time during the deployment, we have actually the old version of this platform running and the new one as well. And then we gradually migrate with this router, with this load balancer in front of the two, from the old to the new one, and then we tear down the old one. In this way, we are sure that the application is always running, and we are not causing downtime. And last is a IoT project, let's say. We've built an IoT platform for one of our clients. And of course, now everybody wants to have everything integrated and be able to control all their devices from a single point. And in this scenario, the Nest Hub is one of the most popular. So we managed to do this integration with the Nest backend using containers, since the whole infrastructure was based on serverless technology. So to leverage the integration with Nest, we need actual machines, and we thought that containers were best for that, because we are able now to start small with little resources, and when the more and more devices are being integrated with Nest, we can easily scale out. I will then leave to Danilo the end of this presentation. Thank you.
So thank you, Federico. So nothing to add. It's just the fact that so you are here. So some of you have already a good experience with containers. Some others probably are approaching right now. But please profit by this day. So Rick and I and our colleagues are here. So if you have any question, any curiosity, any doubt, if you want to double check your knowledge, or you want to understand a bit better about containers, feel free to reach us, to reach AWS, to reach Reply. So we have a booth downstairs. Hopefully we will see you then and have a nice talk with you. Okay, Rick. So thanks. I leave you the floor now. Thank you very much.
So a big thank you to you guys for sponsoring today as well. So I'm just going to do a very, very quick summary, and then I'm going to let you all go and have a drink and something to eat, so release you from this room. So our container landscape, you can see it's quite varied, ECR, EKS, and then our Fargate modes for taking that infrastructure management away from you. We're going to dive deeper into some of these sessions later. The next one on is Brent doing ECS, and then Christoph is going to come and do EKS, and then it's back with me again for Fargate. So one thing to say is that ECS for Fargate is only in US East 1 at the moment. So a big thank you, and this is our schedule going on. There's a little bit of discrepancy with the slide over there, so we're going to figure out what's going on with that. But these are the sessions coming up today, the first 3 at least. If you've got anything that you're building and want to let us know about it, and for a use case so we can showcase it at our summits and at our dev days, please get in touch with us. Reach out to us. We've all got Twitter handles. We'll all give you our email addresses if you come up and talk to us. Mine's quite easy to remember. It's rjh@amazon.com. If you've got a great use case, let us know and we can showcase you and put you out. And thank you very much. Please follow me on Twitter. Thank you. Cheers.